Hi, my name's Nadine Wiggins. I'm the Senior Data Linkage Officer at the Tasmanian Data Linkage Unit located at Menzies Institute for Medical Research and part of the University of Tasmania. Just quickly before I begin, the Tasmanian Data Linkage Unit, or TDLU, is a member node of the Population Health Research Network here in Australia and funded by the Australian Government under the National Collaborative Research Infrastructure Strategy, or NCRIS as it is commonly known. Tasmania is an island state of Australia, the smallest of 6, with 533,000 persons in 2019. It is considered to have an ageing population, with Australia's oldest median age at 44.5 years. The TDLU supports data linkage activities both in Tasmania and Australia. The TDLU works in close collaboration with the Tasmanian Government Department of Health, other state government agencies, colleagues in the University of Tasmania, the Primary Health Network and other interested parties undertaking research, policy development or strategic planning using linked administrative data. Now on to the presentation. The TDLU undertook data linkage for an important Tasmanian study which aimed to examine the gap between the high community prevalence of chronic kidney disease or CKD and the low use of dialysis. The principal investigator of this research is Professor Matthew Jose, Professor of Medicine and Nephrologist at the Royal Hobart Hospital in Tasmania. CKD is a significant and growing public health burden in Australia, with Tasmania having the highest state prevalence of CKD for non-Indigenous Australians. Conversely, Tasmania consistently reports the lowest incidence and prevalence of dialysis in Australia. The study population consisted of any person having a serum creatinine test from 2004 to 2017, a 14-year period, from 2 pathology providers in Tasmania. One provider services the state's largest public hospital in Hobart, and the other provides private pathology in both community and hospital settings across the state of Tasmania. In combination, these 2 providers undertake the majority of pathology services in Tasmania, with the private provider representing 80% of the cohort for this study. The private pathology dataset consisted of approximately 3.9 million unit records. After linkage had been completed, this dataset represented approximately 490,000 individuals in Tasmania. The cohort was linked to the following datasets for the same 14-year period: Australian and New Zealand Dialysis and Transplant Registry, known as ANZ data, Tasmanian Public Hospital Admitted Patient Episodes and Emergency Department Presentations, Tasmanian Fact of Death and Cause of Death, and the Tasmanian Cancer Registry. The focus of my presentation is to discuss the linkage of the private pathology dataset, some of the challenges it presented, and what was learnt through the process. As previously mentioned, the data spanned 14 years and consisted of all serum creatinine tests undertaken in Tasmania by this provider. The characteristics of the dataset pose some challenges for probabilistic data linkage, including no unique patient identifier to identify an individual in the cohort. The data represented an older population, with 85% of all tests for individuals aged greater than 40 at the time of the test. Previous data linkage undertaken by the TDLU has shown the existence of common names in the Tasmanian population. For example, the most common first names in this cohort for females were Margaret, Patricia, and Helen, and for males, John, Peter, and David. The most common surnames were Smith, Jones, and Williams. Data held in the TDLU's master linkage map shows that the use of nicknames in the older generation is common, as is the use of a middle name for many services instead of a first name. This project was no different, and particularly evident when linking to death records. For example, a person may be referred to as Tony across datasets. However, the death record will have the individual listed as Anthony. Other common examples include Betty and Elizabeth's, Marg and Margaret, James and Jim, and Robert and Bob. Now, given the 14-year time span, multiple name and address changes over the time were common. Changes of surname resulting from marriage, divorce, and remarriage are common challenges in data linkage and evident in this project. Australian residents receive a range of public healthcare services through the system known as Medicare. A person's Medicare number was provided as a linkage variable for this study. An individual's Medicare number can change over time, including when a person changes their name or family circumstance, and as a result, the Medicare number was not found to be a reliable linkage variable. Now, given there is one main provider of private pathology services in Tasmania, the occurrence of all members of the same family sharing the same address, and in the case of spouses and children, the same surname was common. This posed additional problems during probabilistic linkage, as individuals sharing the same attributes yielded a high match confidence score during linkage. One of the more interesting characteristics of the pathology dataset was the inclusion of data for non-human subjects, such as animals. These were generally easy to identify. There was also data contained in the pathology dataset that was not attributable to an individual or human, and these were removed prior to linkage. Before loading the pathology data into the TDLU's linkage system, exact record deduplication was conducted. This reduced the size of the file from 3.9 million individual records to 590,000 records. Rows of data with an exact match on surname, given name, date of birth and sex were excluded, as well as rows with an exact match on surname, given name and Medicare number. The pathology data was subsequently loaded into the linkage system and a process of probabilistic deduplication undertaken. Now, the TDLU conducts manual clerical review to identify and fix false positive links where two individuals are incorrectly linked together. Previous linkages of medium to high quality data sets typically results in clerically reviewing between 0.1% to 0.7% of total records imported. For lower quality data sets or data sets with problematic characteristics, the amount of clerical review can be closer to 5% of total records. In the case of the pathology dataset, 47,000 groups were identified for clerical review, representing approximately 8% of the total number of records. Time and resource constraints meant that this many groups could not be manually reviewed. So why were there so many groups for review? A combination of factors were at play. The linkage threshold we used was potentially too low. However, it was the default threshold used for all previous linkages performed by the TDLU. Time pressures existed that prevented deduplication to be run multiple times. The dataset characteristics that I previously discussed made linkage more difficult. The two biggest contributors were multiple changes of address and name over time, and individuals with very similar characteristics, such as families, spouses, children, who were grouped together due to high confidence scores. In order to determine options to reduce the number of groups for clerical review, samples of results were derived at various confidence levels to look for patterns in the data and identify options to apply bulk updates to reduce the number of false positive matches. This analysis uncovered the following issues that were resolved using MS SQL queries. Specifically, the queries resolved groups that contained partners with the same surname, twins, siblings, father-son, mother-daughter, males and females, individuals with very familiar or similar characteristics, often members of the same family or individuals in nursing homes, males with different surnames and Medicare numbers, and groups containing individuals with too many differences across key variables. The results of the various queries were thoroughly checked before groups were split. Now, the TDLU would usually allow probabilistic deduplication and a small amount of clerical review to resolve these issues. However, the sheer volume of groups for clerical review required these additional interventions to be made. Overall, the number of groups marked for clerical review were reduced by 42%. More importantly, there was an overall reduction in the number of groups requiring review in the lower confidence ranges, with a significant reduction of 60%. Sampling was undertaken at the higher confidence ranges, and an estimate of the number of false positives calculated for the groups remaining. This pathology linkage was the largest linkage undertaken by the TDLU, with many lessons learnt. Significantly, it is very important to understand the characteristics and quality of a dataset prior to linkage. While this may take time upfront to investigate and clean the data, the effort taken should yield improved linkage results and reduce clerical review. Knowing the characteristics and composition of a dataset better informs how the TDLU designs its overall linkage strategy, and we will be better prepared for future linkage of pathology data. I would like to acknowledge my co-workers in the TDLU who assisted with this project and all the data custodians who contributed to this research. Thank you for your time, and I hope this presentation provided some useful tips and on issues to be aware of when linking large pathology datasets over an extended period of time. Thank you.